everyone, welcome back to No's Chem Corner. Today we are continuing the AP Chemistry Basic series. The things you should know before you are taking the actual AP Chemistry. Definitely this is useful for Honors Chemistry too. The full playlist for the series I'm pinning somewhere here so you can check it that one also. Let's get into the video. So in today's video, we are continuing the nomenclature of compound. So do you remember in first video we told like there are different kind of compounds are there, right? So before going to name those things, first you need to categorize them like covalent or ionic like that. Okay. So ionic compounds means what was ionic compounds? Metal and non-metals. Okay. When metal and non-metal combined, that is what you mean by ionic compound. For example, again sodium chloride. Sodium is metal and chlorine is a non-metal. So you can say this is an ionic compound. Then you have to follow ionic compounds rules. Okay. But here we are doing with a covalent compound. So if you are not seeing that video, you just see that one. Okay. That is for ionic compounds nomenclature. And today we are going to discuss with the covalent compounds nomenclature. How to name the covalent compounds or otherwise called a molecular compounds. Okay. So molecular compound means first of all what is molecular compounds? Both are non-metals. Okay. For example, CO2, carbon and oxygen, both are non-metal. So it's a covalent compound. SO2, sulfur and oxygen, both are non-metal. So it's a non-metal covalent compound. Correct? CCl4. So it's again carbon and chlorine, both are non-metal. Okay, so this is these all are covalent compounds. So if you are not aware about these things, you just see that video. Okay, in that video we are telling all these things. Okay, like how do you know? Like in with the periodic table, we already shown which side is metal and which side is non-metal. So by using the periodic table, you can easily identify which is metal or non-metal like that. Okay, so if you are not seeing that video, first go with that video. Okay. Right. Anyway, if molecular compound is your thing, how do we name molecular compounds? Okay. So this is not that much of difficult like ionic compounds. It's so easy. So see, this is there is no nothing to like by heart. Like there we studied so many polyatomic ions and different rules are there. But here it's very simple. You just want to concentrate this one. So see the rule: prefix first element, prefix second element, IDE. That's all. Okay. What's the rule? Prefix, then first element, prefix, second element, and IDE. That's all. So what do you mean by this prefix? Which means it indicates the number of atom. Okay. So if one atom is there, the prefix is mono. 2 means di, 3 means tri, 4 means tetra, 5 means penta, 6 means hexa, 7 means hepta, 8 means octa, 9 means nona, and 10 means deca. So these are the prefixes. That's the only thing you need to know. Okay. For example, let's see carbon, CO2, CO2. So how do we name CO2? Ah, and one more thing is there. See the rule. Mono is not needed for first element. Okay. So see here, carbon is how many number carbon is there? Just one only, right? So usually what is our rule? Prefix. So what is the number? Mono is the prefix you need to write, right? But the problem is what? Mono is not needed for first element. So just carbon. You can start with you can omit that prefix mono. You can omit from the first one. So what should be the name? Carbon. Yes. And how many oxygens are there? CO2. So 2. So 2 means the prefix should be di. Okay. Carbon, di. And see second element is oxygen with the IDE. So oxide. So carbon dioxide like that you can name. Okay. So similarly, SO2, how do you name? SO2 again, sulfur is one in number, so no need that mono. So you can write sulfur dioxide. Okay, sulfur dioxide. What about N2 or CCl4? CCl4. Okay, so carbon. Uh, Carbon is again one in number, so no need of not of writing the mono. Carbon Four chlorines are there. So four chlorines. So see the number four chlorine means tetra is the prefix. So you need to write carbon tetrachloride. Okay, that's all. And what about N2O5? N2O5. Okay. So see, nitrogen this time is not one. Nitrogen is two in number. So if two, definitely you need to use the prefix. So yes, dinitrogen and 5. So 5 means 5 oxygens are there. So which means the prefix is penta. But dinitrogen pentaoxide is not wrong. If the next one is O starting with the O, then you can just write pentoxide. Okay, pentaoxide is not needed. Pentoxide is correct one. Okay, so similarly tetraoxide is not needed. Tetroxide. Oxygen if it the in the letter, then you not need to use that A. Okay, hexoxide or heptoxide, like that you can write. Clear? At the same time, if penta, suppose N2Cl4, sorry, Cl5 is the stuff. How do you name? This time dinitrogen pentachloride. Okay, so pentachloride, like that you can write. So that's all the rule of covalent compound. Okay, now you just tell me what about MgCl2? MgCl2. So how do you name? MgCl2, can I write magnesium because one in number, magnesium, so one in number only. Magnesium chloride, dichloride. Is it magnesium dichloride? Is that the stuff? Okay. Is there any wrong with the magnesium dichloride? Because magnesium is one in number, mono is not needed, and chlorine is two in number, di is the prefix. So dichloride. Everything is correct. Is there any mistake? Right. Maybe you may figure it out. Right? This is wrong. Why? Because magnesium dichloride is absolutely wrong because it is an ionic compounds. See, very important. That's why we are studied ionic compound have to categorize first. Okay, before naming the compound, first categorize whether it is an ionic compound or covalent compound. If it's an ionic compound, these kind of prefixes di, tri things are not there. Okay, ionic compound, when you are doing, you have to follow the ionic compounds nomenclature rule. Covalent compound have to follow the covalent compound nomenclature rules. Okay, so this one is ionic compound, we studied already. How do you name this thing? Just magnesium chloride only. Correct? Yes, because magnesium, you are it's definite. There are charges always plus two, so no need of parenthesis. And chlorine is just an atom. It's a binary compound. It's not like a polyatomic ion. So it's simply magnesium chloride. Okay, so magnesium is a metal. So Cl is non-metal. That's why it's an ionic compound. So be careful about this kind of stuff. That's all the ionic compound nomenclature. Okay. Right. Then we can move on to the acids. How we can name the acids. So acid is another category. If it's an acid, how do you name the acid? Okay. So first of all, acid means H plus giving substance is what we called acid. So something with H plus. H plus is actually acid. Again, acid is also two kind of acids are there. One is called binary acid and the other one is called oxyacid. Okay, what do you mean by oxyacid? Means oxygen containing acid is oxyacid. It's very easy. Like as I told you, acid means H plus containing stuff is acid. So definitely one is H plus, then there should be a negative part. Some anion is needed, right? If that anion is containing oxygen, then it will be oxyacid. If it is not oxygen containing acid, like oxygen, not oxygen containing anion, then it is called a binary acid. Okay, so this is binary acid. Anion does not contain oxygen atom. For example, H plus, and the next one, the filling anion is suppose Cl minus, then HCl. HCl is a binary acid. Suppose that minus charge is like sulfate, sulfate means SO4. 2 minus is the charge. So see, 2 minus is the charge. So H plus, we need 2 H plus. So that's why you can write H2SO4. Okay, got it? H plus actually. So in order to combine, like in order to make the charge, they need 2 H plus. So how do you name the stuff? Like how do you write the thing? H2SO4. So H2SO4 is an example of oxyacid. It contain oxygen. That anion contain oxygen. Okay, clear? So two kind of acids are there. One is oxyacid and the other one is binary acid. So see, HCl will becomes HCl. So no charge. Okay, while you writing the stuff, there is no charge. Okay, right. Suppose it's a binary acid. How do we name the stuff? Binary acid, see, prefix hydro is needed and then suffix ic and acid, ic acid, which means, again I'm writing HCl. So HCl means hydro is needed, right? Hydro, because it's a binary acid. So hydro and the suffix ic acid. So base is what? Hydrochlorine. So hydrochloric acid. Okay. So ic acid will be the suffix, ic acid. So hydro is needed for binary acid. Then, so for a HBr, how do you name HBr? Again, it's a binary acid. Oxygen is not there, which means hydro is needed. If oxygen not there, hydro is needed, like that. You can tell. Hydro, and yeah, bro means so hydro, bromic acid. Bromic acid. Okay, clear? That's all. Binary acid. Now let's see what is oxyacid. See, oxyacid we already studied. Polyatomic ions we studied. How do we name? Like, what do you mean by this? Aid, nitrate, nitrite. We already discussed everything. Okay. How do we memorize those things? I'm already provided all the rules for and easy way to memorize this polyatomic ions in that video. Okay. So just again, I'm telling, just please watch those video, just one video. Then you can write this one is easily. Okay. For example, this oxyanions is again two time, right? We studied at that time. For example, nitrate. How we studied? Nitrogen two compounds are available. One with a lower oxygen, NO2 minus, and the other one with a higher oxygen, which means NO3 minus, right? NO2 means ite, nitrite. Lower oxygen will always end with a ite. So this one is called nitrite, and NO3 minus is called nitrate. Okay, so that's the oxyanion. So just imagine hydrogen is H plus, okay, and NO2 is there. Like NO2 is the anion. Then HNO2, like plus and minus just cancel out. Okay, so one hydrogen is sufficient in order to cancel out this charge. So HNO2. So if it is N with the ite, the oxyanion, N with the ite, you have to say S acid. Okay, as acid, which means nitrite. So this one will be nitrous acid. So no hydroterm. See, very important. There is no hydroterm. Just oxyanion name with a S acid. Okay. And if the oxyanion is N with 8, nitrate, then what should be the acid? See, HNO3 the acid. So you have to name it acid. But again, no hydroterm. Okay, so HNO3 is just nitrate, like nitric acid. Okay, nitric acid. Clear? That's the rule. So that's how we need to write the acid name. So three kind of acids are there. Basically speaking, binary acid and oxyacid. Oxyacid is again two kind is there. One with oxyanion N with the I and oxyanion N with the 8. If oxyanion is N with the I, as acid. Oxyanion N with the 8, ic acid. Okay, binary acid means hydroic acid. Hydro and ic acid is there. That's the three rule. Okay, now let's see how do you tell this one. H2S. Let's see, you can comment this thing. Okay, H2S. Just pause the video and comment the answers and then back to the thing. Okay. So see, H2S is again a binary acid, right? It's a binary acid because no oxygen. So definitely hydro term is needed. So hydro and yeah, ic acid. Before that, it is sulfuric. So you can write sulfuric acid. Hydro sulfuric acid. Okay. Then what about this one? Here sulfate. SO4 means sulfate. So it's ic acid. No hydroterm, just sulfuric acid. That's the difference. Just sulfuric acid. Okay. Not hydro, just sulfuric acid. Then HClO. Do you remember we studied HClO? So what is the name of like ClO? ClO is a hypochlorite, right? ClO minus was hypochlorite. So this one is hypochlorite actually. Chloride, hypochlorite. So it's hypochlorous acid. Okay. And ClO2. Do you remember ClO2? ClO2 is chlorite. So it is chlorous acid. Chlorous acid. If any doubt, you can see that previous video, the last video about polyatomic ion. Okay, at that time we studied all these polyatomic ions. Then ClO3. ClO3 minus, the name was chlorite. Sorry, chlorate. Okay, so this one will be chloric acid. Chloric acid. Okay, because 8 it's end with a chlorate. And ClO4 also we studied there. It is perchlorate. 8, so perchlorate was there, so it's perchloric. Okay. uh, Chloric acid, perchloric acid. In that way you can name all the stuff. Okay. So basically you need to know the polyatomic ion. That's a very important thing. Okay, ClO4 was perchlorite. If you know that one, then only you can write the name of the acid. Okay, so this was perchlorate and this one chlorite. Okay, and this one was chlorite. That's why we are writing like ClO2 minus is chlorite. Then this one is hypochlorous means hypochlorite was the ClO minus name. Okay, in that way you can easily write the acid names. That's it for today's video. If you found this helpful, give it a thumbs up and share it. Subscribe to Anu's Chem Corner for more videos. I will come back with another basic topic in next video. Bye.